Hi there guys, welcome back. Today I want to talk to you about resistors, diodes and LEDs. We are not going into the physics of each component, but we're going into how we're using them and how you should think about them. So I've set up a small circuit, which is right here. Just have a 9 volts battery hooked up to this small battery power supply. What you want to notice is the power is on the outer bar. Let's disconnect this a bit. And the black bar is minus or negative. So, first thing first, LEDs. They come in many shapes, many colors, and from many different factories. What's primary concern about these is the light, of course. Usually you would say something like the long leg is from plus and the short leg is to minus, or vice versa. Usually you would be able to know. These days I got some that are both ways opposite each other's, where the long leg is the anode and the other one is the long short leg that is the anode. But one thing I have noticed that's equal for all of them is when you look from the top, it's very hard to see on this Logitech webcam. Yeah, don't buy that. On one side of the legs, it's as if it's filed flat. On the other side, it's still round. What I have learned is the flat side is negative. And yeah, there we go. So I'm going to put my LED negative into the negative bar and the other one up here in the breadboard somewhere. Now in order for this to work, we just put plus into the other side. The problem with this is, you can see it, there we go, it works for a short time. If we keep doing that, the LED will get too much current, well, maybe not from this battery because it's almost flat, but from a normal voltage source it would drain out or heat up this LED, and the small metal plates inside would either break or melt together and the LED would stop emitting light, effectively just being a short circuit or just disconnected. So to protect that, we're going to limit the current. And the best way to limit current, let's see, I have a oh yeah, there we go, on the desktop, of course. Going to switch to our desktop, there we go, is this funny image. So imagine over here we have our LED. Over here we have our power supply, and we're going to send power through the wire, which is illustrated by this black line right here. And the problem is, if we send the power through unhindered, it would just burn out the LED. So in order to protect the LED, we're going to introduce, well, we're going to limit the amount of current that can get through, right? And the way we do that in electronics, you can see here they're basically just making the hole smaller. So if you imagine current running through here, it can only put this amount through this entire thing, right? So this guy ohm up here is representing the resistor. This guy volt is representing our power source. He's pushing amps through. And he doesn't really fit, but he's getting there. So that's basically what's going on in our electrical circuit. I found a small website I'd like to show you, because it's very important to know how resistors work. Well, basically they are just converting electricity into heat. Unfortunately, yeah, let's try this just a bit. I'm going to zoom. Yeah, because Google do not like us showing Google ads on the website. Well, you can see the website up here. It's just the first thing I googled was I googled color code calculator, as you can see right here, and this one showed up. So I just clicked it and it looked reasonable. Here we go. This is a table of colors for our resistors. As you know, they have these round bands on them. Let's switch to the cam for a second. There we go. This resistor has 2 red and 1 black and a gold, right? Maybe it's a brown, no, it's orange. It's a bit hard to see, but it's roughly like that. But what's important for us is the 2 red. So when we switch back to the calculator, we can see that it's 2 red, meaning band 1 is red, that's 2. Band 2 is red, that's 2, meaning it's 222. There's no band 3. Well, yeah, there was, but band 3 is only if you have 5 bands. This one only has 4. Oh, okay. Okay, the next band is brown or black, meaning it has a multiplier of 10. So 222 times 10. Well, that's 220. Well, that's correct, because that's the amount of resistance, or ohms, if we want to look back at the image. Ohms is the value we use to measure this. So there we go. So this guy is 220 strong. And the last band was gold. Gold is just a purification indicator. You can see it's plus minus 5%. It means how precise is this to 220? Well, I can measure that with a multimeter if I wanted to. I don't want to. So I want to hook this up to my circuit. So where should I put it? Should I put it after the... Let's remove all these other components. So there we go. So should I put it after and down to there we go, like this. So right now the current comes in through the resistor and this way out through the LED. Or should I put it on ground? Maybe turn the LED around. Well, that also works, because that's the funny thing with current. Now the power is running the other way. Current don't really care if you put the resistor before or after the LED, it will always work. It's limiting the current that runs through. Out here the current is still high, but in this small circle right here with the LED, it's very low and it's limited by this resistor. Okay. That's the basics of it, right? And you see this LED is sort of a red. It's very hard to see on this camera. This one might be a different color. We can't really tell until, well, yeah, it's green. Until we plug them in. Okay, now let's introduce another thing. So I'm just moving the resistor down here so we have a space. Now I'm going to put this guy in the same circuit. There we go, he's in, but nothing is happening. What is this guy? Well, you can see he's black and he has this gray circle around it. It might be a different color, that's not important. The important thing is this is called a diode. Just like this one is called a light emitting diode. These two do the same thing, except this one does not light up. The current can only run through one direction through this because it has to jump. The same with this one. So if I take it out, turn it around, there we go. Now it works. The current can run from plus all the way around to minus. This diode is important. You should consider this as a one-way valve. We can use this in many circuits to protect the circuit behind them. This is a normal diode, and there are many different diodes out there. These are the ones we want to use in our normal discrete circuits, but be careful because there are also diodes called something like Zener diodes, which actually can allow current running through the other way. We don't want those in this project or for this series, but normal diodes like this one is okay. These are of course also rated in different values, which can be googled by this number. So now we have a small circuit. People are then going to ask, but hey, you put a 220 resistor in this circuit. How do you know this has to be 220? Well, to be honest, I didn't. But I have built circuits like this many times, and I know from 0 to 12 volts roughly. With light emitting diodes, I can use resistors from a range of maybe something like 150 to 400 ohms, and I'm okay. I can use higher, but then the light will just be really low or really high. The thing with the LEDs are they can run from, usually depending on the manufacturer of course, from 3 volts to 10 to 12 volts, but you need a resistor and they will usually be fine. The way to find the resistor is, well, you need to know the current across this resistor. You can measure that using a multimeter. We're not going to do that because we know this one is fine. But let's just do one little theoretical thing. I found another website. You can just Google resistor calculator, right? I'm just googling it this off screen and I'm pulling it in. Yeah, it's zoomed because of the adwords. Yeah. To calculate resistor needed for a simple circuit, simply take the voltage away from the source and apply Ohm's law. R equals the resistor, Vs means the voltage source, voltage from the LED, and the current from the LED. Well, we know the voltage already because we know they run from anything between 3 and 10 volts. So we're just going to put in a average value. The voltage source is 3 volts in our circuit, 5 volts, because we are using the small power supply. So maybe our LED is on at 3 volts, so that's 2 volts divided by the current. And you can see they even made this nice circuit. We're not going to go over that right now. We're keeping it simple. LED, light emitting diode, a diode, and a resistor. That's all we need to know right now. So the reason we need to know that is because in our last video we went over power supply. This video we went over LEDs, resistors and diodes, and we're going to use these in our next video. Our next video we're going to be utilizing one of the Arduinos and actually programming some LEDs to turn on and off. So that's going to be fun. Thanks for watching. Comment, rate, subscribe, and of course if you have any ideas just pop them in down below, and I'll see you next time. Keeping it simple. Later.